Okay, in this video I'm going to demonstrate the operation of a piston-actuated valve over here with position switches on it. I'm going to demonstrate the operation of it with DeltaV version 12.3.1. So to start things off here, we'll demonstrate it in operation, and then I'll just show you kind of how it's configured. So here I want to hone in on this graphic right here, HC-101. This is our piston actuated valve. If I click on it, it brings up this display right here. These are all pre-configured, pre-built displays in DeltaV. Right now, the valve is open. The set point, or what the operator had told it to go to, is the open state. So white indicates kind of the set point. Yellow is our process variable. So if I click close, we can hear the valve shut, and you can see that it's in its closed position over here. If I click open, you can hear it open, and it is in its open state now over here. So that works great. The other thing that we have configured on here is a level switch. Got this on our little toggle switchboard here, LSH H101. Right now, it's closed. If I open that, you can see it alarmed, it shut our valve, confirmed it closed, and it's now interlocked. We've got this little I symbol here indicating that it's interlocked out. If I clear that level switch now, it's closed, indicating that the level is good. It's no longer high leveled. You can see that we have this configured so it requires a reset. So the operator would have to confirm that he knew that the alarm was in, and now he's going to reset and say, yep, we're good to go. Because right now, if I try to open the valve, it's going to hold me out and say, due to a permissive or interlock condition, we cannot change the set point. Reset it, and click open, and the valve opens. So now just to kind of show you guys the programming, how this works. So starting off, we'll start in DeltaV Explorer. So we created a control module called HC-101. It was a template of VLVNC-12 up here in the library. Drug it down and started editing it. So I will open up HC, we've got HC-101 open up here now. We dropped in a DI block. This was for that level switch. The level switch is normally closed. That means when there's no level on it, it's closed. What we had to do though on the DI block, let's see if this parameter is available. I might have to go offline here. DI block, we want IO options, which is right here. You can see this is the level switch tag that we have linked for the actual physical output linked to our system in IO in. IO options here, if I double click on it, it gives us the option to invert the signal. So a normally closed switch, which this is, we're representing a normally closed switch, no level, it'd be closed. We want to invert that signal to a 0, because on this DC function block, shutdown coming in, when that becomes a 1, that's what produces that interlock that we were seeing that we had to reset. Now, so that's kind of the basics for that DI block. It gives us the ability to do the inversion. If I click on the DC block, which stands for device control block, we have two inputs connected to it. One for a closed switch and one for an open switch to indicate the position of the valve. We also have an IO out value connected. The IO out is to energize the solenoid that gives the valve air. So those guys are all configured down with IO in 1, IO in 2. ZSO is our position switch open, and ZSC is our position switch closed. They've been linked to their physical outputs. IO in out 1 is XV-101. It's also linked right here down in the parameters. The other item that I wanted to highlight is the state mask that the DC block uses. State masks. I'm going to double click on it. It brings up this screen. There's an active and a passive state. The active state is when we open the valve or energize it. When it goes to the open state, we're looking for input 1 to be true and input 2 to be false. This is for the open position switch. If this switch closes, it's going to indicate the valve is opened. But we don't want the closed switch to be true, so this needs to be unchecked. Passive state, when we go to the passive state, we're closing the valve. So on input 2, that's where we have our closed switch wired. When the valve closes, the closed switch is going to close, indicating that the valve is closed. The open switch will be open, indicating the valve is not open right now. Over here in our outputs, if we are in our active state when we're trying to open the valve, we energize the solenoid, so this needs to be checked on for our output 1. And then when we go to the passive state, we want the solenoid to de-energize, so this needs to be unchecked or false. If at any point we change it, if we go to the active state, when we're opening the valve and the proper switches don't close and open, that will throw an alarm. So just to demonstrate that, I'm going to close this just to demonstrate the state mask. We'll go back, and what I'm going to do here is I'm going to open the fuse for our position switches. So I'll open the fuse for the open switch. That means now we will not have status indicating that the valve is open. You can see it goes to the undefined state right here, right? So it's looking for that open switch to be closed right now, saying, yes, we are open. If I go to this closed state, it's still undefined. Oh, sorry, it goes closed because the closed switch closed. If I open that switch as well, though, right now, it goes undefined. The valve will open and close, but it's alarming right now because the state mask is saying, hey, the proper inputs aren't in the proper position. They're not the proper. Right now we're closed and the closed switch is open, right? Both the switches are open, so we're undefined. So we'll put these back in, put the fuses back in, and now you get the proper status. It's saying, yep, we're closed, and that's what we want to be. We want to be closed right now. I'll open it, close it. I can reset this alarm, and now the valve is functioning properly with no alarms. So hopefully that demonstrates how you can use the state masks and the device control block with the VLVNC-12 template in DeltaV. The last item, so this is a template. There's also templated graphics that we were working with here. If we go back to our HMI DeltaV operate, I'm going to toggle to configure mode, Control W. This graphic right here that we used, this is from FRS modules theme. I'm just going to scroll up under dynamo sets. So we've got the dynamo sets up here, FRS modules theme, double click, pre-built graphics. And the one we were using was this guy right here. We just drug it into the project and then linked it to our HC-101 control module that we configured. Click on this graphic. You can see the graphic that we used was this guy right here, the MD1_VLV_. We linked it to the HC-101 control module that is right over here, HC-101. So hopefully that gives you a good idea on how the device control block works and the state masks work with running our piston actuated valve here.